20 equals x, or x equals 20. And so our first answer should have been D. D was correct on the first one. Remember, if you made a mistake, change it now. Don't be too proud to change your answer. There was a few of you that got this wrong. All right. Luke, you don't have to have it up anymore. Oh, okay. No, you're fine. No, you can hold it up as long as I just want to make sure you're aware. All right. So the next one I'd look at is maybe Z and this. So I know that this angle here is now 40 degrees. Now I'm going to highlight these two angles. I'm going to highlight this one and this one. Can someone raise your hand and tell me what type of angles those two pink dots form? Will? Same side interior. Can someone else raise your hand and tell me what's important about same side interior? Yeah. They're supplementary, so they add to 180. So we could come up with an equation that says like 40 plus Z equals 180, or we might go the full route of going, that means 2x plus Z equals 180. Both of those will work. So I can either put 2x or I can put 40 because I know that equals 40. Now if I plug this in there, we have 2 times 20, which would be 40, plus Z equals 180. So we should have came up Z equals 140. Now let me highlight Z and Y with orange dots. Can someone new raise your hand and tell me what kind of angles those are? The orange dot angles. What type of angles are those? Oh boy, yeah. They're same side interior, which means they are supplementary, so they equal 180. So that means that we have Z plus Y equals 180. But we know Z equals 140, so you should come up with Y equals 40 degrees. Most of us had this. We had 2 people that got this wrong, but our number 2 should be 40 degrees. Questions on the bell work? Yeah?
Do you have to know each way that it could be 40 degrees, or can you just know that it's corresponding?
You could have known as corresponding as well. Perfect. That's great.
I mean, like...
Yeah, so you could have said 40 and Y are corresponding, so they're 40 degrees. Awesome. Awesome. Yeah, any one of those, as long as it's valid. You don't just make up some rule. Yes. So did you all hear that about Griffin? Griffin said, well, I just saw that Y and 40 were corresponding angles, so they're congruent. I made you go the long way up here to show you can go through all this stuff, but I would use corresponding as well. All right, other questions about work? That's a great question. They're all great questions. Going once, going twice. All right, questions from the homework. We had, 3.2 homeworks? A lot of good questions in there. Let's get some good questions from me. Yeah. I can later. Yes, Michael. 17. Oh, I love that problem. I love number 17. It shows me not only can you put together the angle things, you can think critically about something. I'm going to take a picture of what I drew, and let's talk about why I drew it. And with my drawing here, this is what I'm going to point out. Always a good idea, I'm going to highlight my parallel lines, because we know everything has to deal with these parallel lines. Maybe I'll make that a little thicker. So this line is parallel to this line, forming different transversals. I have one transversal going here. I have one transversal going here. What I'm going to focus on is this one here. I'm looking at this being the transversal that I'm focusing on. Now, Michael, not to put you on the spot, and if you can't answer this, that's fine. What kind of angle would the green dots be? They're the same side interior, which means they equal 180 degrees, correct? So now this green dot is the green dot I'm focusing on. This one right here. That dot I'm focusing on because it's not one angle. It's actually a combination of 2 angles. It is actually, I'm going to use the angle addition identity or postulate to say that this angle Y plus this angle I didn't have the measure of originally must equal this entire big angle. And I said, well, you know what? If this is 70, then this big angle here I used to have highlighted must be 110 degrees. So when I add Y plus this angle, it has to equal 110 degrees. Well, I used vertical angles to go, okay, this missing angle right here is actually 50 degrees. So now I have a little formula. It's 50 plus y equals 110 degrees. So that's what I have coming right from here. This spot right here is it's pointing me y plus 50 degrees equals that 110. So y would just equal 60 degrees. Does that make sense so far? Okay. Then x should be semi-easy because those are just corresponding angles. 70 and x are corresponding angles, so they're just equal to each other. So sometimes the same side interior angle consists of two angles I need to understand. I can add those together. Good on that one? Are we all good? That one should have been a question. I get that in every single year. Yeah. I can. Can I, 15 I'll do next, but does anyone have questions on this one that I have up here? Flynn.
So why did you do the y plus 50 again?
Well, I guess in short, so I'm bringing up the fact that, let's highlight these again, that this angle here, notice the big angle here and that 70. Those are same side interior. But notice this blue dot covers both of these angles. So this entire thing plus this thing has to equal 180. So maybe another way to look at that is, so if I look at those two blue dots and those have to equal 180, we could say something instead that, you know, y plus 50 plus that 70 must equal 180 degrees. So this blue dot is actually two things. It's y and 50. And this one was just 70 degrees, so you add those both together and equal 180. I just shortcutted it by already subtracting 70 to say it's 110. Is that a little clearer? Yeah. Okay, cool. All right, and then number 15, I think you said, right? Number 15. 15 is kind of one of those puzzle ones where we have to jump around. I'll take a picture of mine real quick. Here's my advice on a lot of these. Don't even look at the letters you have to solve for. Look at where the numbers can go first and see if they can get to the missing variables. So if I start at 120, notice how both these lines are parallel? These will be corresponding angles because I have the parallel line and this would be my transversal. These would be corresponding angles. Well, 120 and x, what is that shape called? What is this shape called? Someone just said it. It's called a linear pair. They form a line. It's two angles that form a line. That's a linear pair. They equal 180. So if this is 120, x must be 60, so it can make that 180. And then I look at here. These are parallel lines as well. Once again, I can highlight this as well, but we should realize that these are corresponding angles. This blue dot, that blue dot, corresponding angles. That gives me 60 equals whatever's here. So that's where I came up with this equation, 60 equals 3y plus 6. That we can't immediately just go to the y. Sometimes we have to solve an algebraic equation to get to that y. Okay? Now, on a test or something like that I'm asking for this information, this equation's worth a lot of points. Less points for solving it correctly. The bulk of your points come from writing it correctly. That's why I'm stressing. On the test, it'll probably say you have to write an equation because I want to see that equation. I don't want to see you guessing and checking your way to the right answer. Okay? Mason, do you mind close your computer? Even if you don't have questions, we should pay attention because I can solve things differently. All right, what else we got? Yeah, go Flynn.
Number 14, question 5.
Number 13. Yeah, that's a good one. We're going to need that one for our next lesson. Not so much today, but for our next lesson, it's a big one. So it's one that's kind of hidden in our packets, and it's under our theorems. We have something called the congruent supplement theorem. It's on that last page. The last page of the thing that says theorems. What that says is if two angles are supplementary to the same angle or the same congruent angles, then those angles must be, in fact, congruent to each other. So this whole proof is showing that 3 is supplementary to 2 and 1 is supplementary to 2, that means 1 and 3 are congruent to each other. Maybe we could talk about that theorem just a little bit further. Let's say I have angle 1, I have angle 2, and I have angle 3. Let's say angle 3 is 110 degrees, okay? Let's say angle 1 and angle 3 are supplementary to each other. And then let's also say 2 is supplementary to 110 as well. So these are both supplementary to the 110. Well, if 1 is supplementary to 110, what does 1 have to equal? 70 degrees. If 2 is supplementary to 110, what does 2 have to equal? 70 degrees. That's where that theorem comes from. If you can show that two angles are supplementary to the same or equal angles, or basically the same angle, then they must be equal themselves. Are you good with that? Okay. Is that good, or just move on? Más o menos? So, I mean, you could do this with anything. I mean, if I say, so this is what the theorem actually says. So 1 and angle 2 are supplementary. And then we could say maybe 3 and angle 2 are supplementary. If you can say these two facts, see how 1 goes to 2 and 3 goes to 2 as well? That means 1 and 3 must be congruent to each other. Better? Cool. All right. I saw a hand up over here. Yeah. I don't know why we still have our computer open. Oh. Well, you should have already had that corrected, right? So number 13. We'd realize that we have parallel lines. So if I look at 13, we do have parallel lines. That's important. So let's highlight our parallel lines. I don't care if it's just on the base of it. These are still same side interior angles. This is my transversal. A lot of times when I draw this, just to help myself, I draw it a little bit longer. So when I highlight it, I draw all these a little longer. It'll help me see alternate interior angles, and it'll help me see same side interior angles a little better. Well, these are on the same side of the transversal. It's between our things, so it's same side interior. Oh, I kept saying internal. All right. So that means that these two angles must equal 180 because they're same side interior. So all we need is 5x plus 4x equals 180. Well, that's 9x equals 180. That gives me x equals 20. It does ask for the values of these angles, so we just put 20 back in for both of them. Cool? All right, what else? Not going to wait too long. We have a lot to go over. Okay, then we will start today's lesson. In fact, before we start today's lesson, I'm going to hand out a new postulate theorem sheet. This is also on our website under those downloads. This will probably, I have a stapler, we can do it later. You probably want to attach this to your other postulate and theorem sheets. So all of these should be out every single day. Every single day you should have your postulate sheet out. So let's go ahead and get our postulate sheets out. Yeah. You did what now? Sure. Yep.
We were working on more problems like these, number 15, 16, 17.
Are we going to work on more of them?
Yeah.
Maybe later in the review section. My advice is just cover them up and see if you can still do them. All right, so we should attach this. I have a stapler later on. We will staple it to our original one because we can use these on the test. I did have several people ask me for additional problems. Hey, you do have a book that you are invited to. I think I have to invite you to the book still. You have a geometry book. You should have been invited in your other class. That's a great place to get problems. You can look at Alex. Alex can have those problems. And I highly suggest, if you didn't know how to do those problems, You have blank copies online, or just cover up the answers and see if you can do them now. All right, it's less about doing more problems. It's more about doing the ones you have correctly, and then we'll get more problems. All right, let's move on. Today we're talking more about proofs. If you can understand proofs, you can understand what we did yesterday. Okay, so we're supposed to state the postulate or theorem that justifies each statement. So yesterday we talked about three big things. That is that corresponding angle postulate, the same side interior theorem, and the alternate interior angle theory. Those are the big ones that are on your sheet. Now there's more on there, but those are the three ones we need today. So our job is we're supposed to state the postulate or theorem that justifies each statement. I need to, first of all, do we have parallel lines? Were we given parallel lines? Now, this is a big question. I know you're like, Mr. Pabian, they're all parallel. They won't be. In our next class, we actually have to prove they're parallel before we can use parallel. So just be happy I'm giving you parallel lines right now, but still do the check. Yes, I have parallel lines. In fact, we can even highlight those parallel lines. Parallel. Parallel. Cool. Then it says 1 and 5. Now, you guys have pencils, right? Highlight them. Highlight 1 and 5 and then just erase them. Well, 1 and 5, are we 100% positive those form 2 lines and 1 transversal? Yes. I can see the transversals, this one M. My lines are L and P. I'm not asking you for that, but you should still know what your transversal is and what your lines are. Okay, what type of angles are those? They're corresponding angles. So can someone raise your hand and tell me the postulate or theorem that says those, in fact, must be congruent? John Keaton? The corresponding angle postulate. That's it. That's all we're asking for in this section. So our next one is 3 and 6. If I highlight 3 and 6, once again, we can just erase stuff. Highlight 3 and 6. That's 3. 6, maybe I'll change the color up a little bit. We'll go green. We should see 2 parallel lines and a transversal, which we do. What allows me to say those are 100% congruent? Griffin? Alternate interior angle theorem. Alternate interior angle theorem. Perfect. All right, you can color them in all you like. I am just going to ask questions now. My next one is C. Measure of angle 6 plus measure of angle 4 equals 180 degrees. Same side interior angle theorem. If you would highlight that, 4 and 6 are definitely on the same side of the transversal M. Our last one says 4 is congruent or equal. Because if we look at 8 and 4, nice job, not even being here, but staying up with it. If I look at 4 and 8, those are definitely corresponding angles. So this would be corresponding angle postulate. All right, let's do a little theorem now. Now, we need to prove that if 2 parallel lines cut a transversal, then same side interior angles are supplementary. I have to prove a theorem, which means that theorem disappears. You can't use a theorem to prove itself. That's like eating yourself. It doesn't sustain you. You cannot use this theorem in here. So that theorem's gone for this one. We can use everything else. We just can't use that. So in order to prove that, they set up this little situation. They said, well, A is parallel to B. That's good. We should go on our drawing and write our parallel lines in. Mark up your drawing. I see lots of lazy people not marking it up. Put my parallel lines. Mason, do you mind picking up your head, please? Thank you. All right, I need to show that 1 and 4 are supplementary. We'd be good if we could use this theorem. I'd just say by this theorem they are, but we can't use that theorem. So we have to do something else. So let's think about that, but let's first put our given down. Do you know at least one person lost points because they didn't put their given down? Yeah. Can you believe it? Easy peasy. Got my given down. All right, so I cannot directly say 1 and 4 are supplementary because I don't have that theorem. Is there something else up there from the angles that I picked that would be supplementary? Yeah.
Same side interior.
Same side. We can't use that one. We're trying to prove that theorem.
What's it?
Yeah.
It says supplementary.
Yeah. Is there anything else that's supplementary up there?
I totally explains.
Okay. Will?
Would it be the show? Or do 1 and 2?
Would it be the Well, we can't say 1 and 4 are congruent because we'd have to use the same side interior. So we have to go somewhere else. We have to figure out a different way instead of saying
Do 1 and 2 for alternate side?
alternate interior angles. We might have to use that. So we could say that. So this is what we do. If I'm writing a proof and I'm not sure what to do, we could just go ahead and mark on here that 1 and 2 are congruent. We can go ahead and go down here and go, okay, 2, angle 1 is congruent to angle 2. There we go. Now we're thinking alternate interior angle theorem. I don't know if you could hear Griffin. Griffin's like, we have a linear pair up there. If I have to introduce the word supplementary and I can't use same side interior angles, the only other way to introduce supplementary on this one is looking at 2 and 4. 2 and 4 form a linear pair. Michael, can we not text in my class, please? So my next step is to actually say that 2 and 4 form a linear pair. So angle 2 and angle 4 form a linear pair. And that's the definition of a linear pair. So we do have to say they're a linear pair first. Now we have multiple paths we can go. What are linear pair? If I get more descriptive about it, what can I say about linear pairs? I can say they're supplementary. What else can I say about it? They equal 180. We have two choices here. We can either say that they are supplementary or they equal 180. Now, I'm going to show you a slight problem with one of those methods. So don't write this down. I'm going to say why this isn't going to work. Pay attention. Don't write this down. I mean, if you do, you're just not paying attention. I could say angle 2 and angle 4 are supplementary. What allows me to say they're supplementary if they're linear pairs? Careful, it shows up two different places. It would be the linear pair, not the postulate. It would be the theorem. The theorem says supplementary. What does the postulate say? It says 180. Here is the problem. See how 1 and 2 are congruent? So doesn't it look like we can put 1 in here? You cannot use substitution unless there's an equal sign. You cannot use substitution unless there's an equal sign. Jake? You cannot use substitution unless there's an equal sign. I'll say it one more time. You cannot use substitution unless there's an equal sign. Yes? We can't use transitive here because transitive would be like 1 goes to 2, 2 goes to 3. If we could, then we can use congruent. If you want to use substitution, you have to change things to equal signs. So instead of this one, I'm going to pick measure of angle 2 plus measure of angle 4 equals 180 degrees. This will be the postulate. Linear pair postulate. Did I ever say measure of angle 1 equals measure of angle 2 yet? No, and I have to say those exact words. I have 1 is congruent to 2, but I don't have them equal to each other. So my step 5 would go measure of angle 1 equals measure of angle 2. What allows me to go from a congruent symbol to an equal symbol? Oh boy. What allows me to go from congruent to equal symbol? There we go. Definition of congruence. Now we can use substitution. I can substitute 1 in for that 2. I know to use substitution because I'm subbing in an element of an equation. Anytime we have an element of an equation, we need to use substitution, not transitive. So now we're going to have measure of angle 1 plus measure of angle 4 equals 180. Why? Oh, I already said that. Substitution. Doesn't pay to trick you on that. Am I done? Did I do it? People have said no. What do I have to add to this?
No, you have to change it to what it actually says.
I have to change it to what it actually says. So this is close, but I didn't change to what exactly it says. So I do have to have a step 7 that says angle 1 and angle 4 are supplementary. That would be the definition of supplementary, right? Thank you. Guys, this is a great, perfect proof. Are we all perfect individuals? No. One person said yes, I'm glad. There's one perfect person in this class, so one person will get this 100% correct. Pretend you're in someone's shoe that doesn't know how to write proofs. They're not strong proof writers. Are those people in here? Yes. There's people in here that are just like, I'll never write a good proof. I'm going to show you we can still get points. Let's say this was a 5-point question on a test. Let's look at this. Let's look at how I grade this. First point, did you write your given and your conclusion? That's a full point for just copying stuff down. That's a full point. Then I would give you 2 points for mentioning linear pair and corresponding angles. Could we all mention that at least? Maybe not a proof. Could we at least mention that there's corresponding angles and there's linear pair? All right, you now have 3 points. There's only 2 points of putting together this proof. So if you put anything that even kind of resembles nice order, you have 4 out of 5 points. That 5th point is that perfect student that puts it together perfectly. So you're fine. If you're just like, I looked at this, I could do the given and conclusion. I could notice that there's corresponding angles, and I could notice there's a linear pair. You have 3, and all you have to do is try to put something down here, and you have 4 out of 5 points. You don't have to be great at proofs to do well on these tests. That's what I'm trying to get apart. So don't just spend your entire life doing proofs when you should focus more on what alternate interior angle are, corresponding angles, and seeing those things. All right, now that spiel's over, let's go on to, I think we have 2 more proofs. This one should go a little bit quicker. So we have, let's go ahead and do our given so at least I can get that point. So we have K is parallel to L. That's my given. Now I'm going to note there are multiple ways to do this one. I have to get from 1 to 7. Mason, you're not on your phone, are you? All right, I have to get from 1 to 7, or I'm sorry, from 2 to 7. I'm going to go ahead and mark that. I have to get from 2 all the way down to 7, and I have to prove that they're congruent. Let's not even do the proof right now. Let's just mark up our drawing to see how I'd get there. I have to get from 2 to 7. Where is somewhere I can go with 2 that I know is congruent to it? Everett? To 5, so I have vertical angles to 5. So I can go ahead and mark vertical angles. Is that points on a proof? Yeah. I marked the drawing and I said what's important about it. Vertical angles. Boom. I have a point. I have 2 points already. Did I do a lot of work yet? That's 2 out of 5 points. Okay, so I have 2 going to 5. Now, I know there's multiple ways. Some of my went a different way, but we're going to go with the way Everett did. He's 100% right. 2 goes to 5 by vertical angles. Is there any way to get from 5 to 7? Massimo? Corresponding angle postulate. So we can go from here to here using the corresponding angle postulate. Guess what I have up here? I have 3 points. Did I even write anything in the proof, really? No. Do I have to know a proof to get a lot of points on these? No. Now, if I could put this in proof form, even close to it, I have 4 out of 5. If I do it perfectly, I get 5 points. So don't get bogged down in doing things perfectly. What I'm trying to stress is don't copy the answer key, guys. I know people on here are copying the answer key for proofs. Doesn't help anyone. Because then you're going to get to the test and you're not know how to do any of this. All right, let's go ahead and put this in proof. So Everett, that was the first thing that happened. He said 2 was congruent to 5 because he used vertical angles. So step 2 is angle 2 is congruent to angle 5. Vertical angle. Is that a postulate or a theorem? It's a theorem. So we should write that. All right, then someone said we can use corresponding angles to say 5 is 7. So I have angle 5 is congruent to angle 7. Corresponding angle. Postulate or theorem? Postulate. Now, if I have to use substitution, I have to change these to equal signs. But if I can use transitive, I don't have to change anything because transitive works with this. Now, our job is to decide, does transitive work here? So I have 2 links to 5, 5 links to 7. Does that sound like we can use transitive there? Yes, so I don't need to change anything. If you thought you were going to use substitution, just change them to measures. So if you wanted to use substitution here, all you'd have to do is measure of angle 2 equals measure of angle 5. Measure of angle 5 equals measure of angle 7. So 2 more steps, then you could use substitution. But we can use the transitive property here. Yeah, Tito.
So you don't have to change it to
Not if you're using transitive. Only if you're using substitution. So for people that have just been using them intermingling, now we have to have that clear divide. If I want to use substitution, it has to use equal signs. If I can use the transitive, which I can here because I have 2 linking to 7, and I can use transitive to make this work. That's a nice power of the transitive because I don't need to have equal signs. If you put them in there, who cares? If you're not sure, change them to equal signs. No harm, no foul, just a couple extra steps. Questions? Okay, we got one more to go through. Remember, your job is not to just passively listen to me. Think of the next step. I know the first step is the given. K is parallel to L. That is my given. I need to prove that 1 goes to 7. That 1 is supplementary to 7. Now remember, all postulates and theorems are out there. There's multiple ways to get through this. I need to introduce the word supplementary. How do I do that? I can't say 1 and 7 are supplementary because we don't have anything that says this equals or is supplementary to that. We'll go Flynn.
1 and 4 are supplementary because of the same sign interior angle theorem.
So you know what I'm going to do? I'm going to point 1 to 4, and I'm going to put same side next to it. So I have 1 and 4 are supplementary. I have 1 and 4 are supplementary. How do I connect 7 to that statement? Griffin? 4 and 7 are congruent because of vertical angles. I have 3 out of 4 points. 3 out of 4 points, I don't even know how to do a proof. Now, hopefully we can put some things down so I can get that extra point, so I can get 4 out of 5. So what I'm going to do is I'm just going to list what was stated. 1, we said 1 and 4 are supplementary, so we'll go angle 1 and angle 4 are sup with you, I don't know. And that's going to be same side interior angle theorem. Then we said 3 is going to be 4 is congruent to 7. Angle 4 is congruent to angle 7. That is going to be vertical angle theorem. All right, now we have to decide, can I use the transitive property? So I would have to substitute this 7 in for this 4. That's substitution. What do I need to use substitution, Tito? I need equal signs. Now, if someone in this class just put 7 in for here and says substitution, you'd lose like half a point. All right, you're really, really close, but you can't quite use substitution. I'll show you an example of that on your homework, because there's one on the homework solution key that's 100% wrong, but you get most of the points. So we need to introduce some equal signs. So let's first say measure of angle 1. Oh, thank you. Why did I put 2? Maybe we're just counting backwards, right? So 4 should be measure of angle 1 plus measure of angle 4 equals 180. Can someone raise your hand and tell me why I was allowed to say that? Yeah. Definition of supplementary. Thank you. I'm going to steal a super hard one. I'm going to say measure of angle 4 equals measure of angle 7. That's definition of congruence. No, I didn't. Nope. It's just my penmanship. It's definitely a 5. It's just, yeah, I should probably rewrite it because it kind of looks like a 4. I'm at a disadvantage. You can see when I zoom in, I can't see anything above it. All right. So are we on step 6? All right. We're on step 6. Can someone tell me what I should do for step 6 now that I have things in equal signs? What should my step 6 say? I'm going to give you a hint. We have measure of angle 4 equals measure of angle 7, right? Why did we do that?
So you get measure of angle 1 through like same side material.
Close.
So would you substitute measure of angle 7 for measure of angle 4?
Yeah, perfect. So we'd go measure of angle 1 plus measure of angle 7 equals 180. Our whole goal, Jack, is to say that these two things are supplementary, so I need 1 and 7 in there. That's the whole goal of this is to...
Substitution?
It would be substitution, yeah. Because if it was transitive, I wouldn't need to do all that work. And then my last thing is to make sure it says the right stuff. So I should say angle 1 and angle 7 are supplementary. And step 7 is going to be... What was that? Definition of supplementary. Good job.
Your word has to equal 180, or is it the...
The theorem says supplementary. The postulate says... And you have the packet. If you're ever confused, look at what... So what I would do is I'd have linear pair highlighted. I'd put a little star by each of them. So if you find it in the postulate, you can read it. If you find it in the theorem... I would find the theorem's easier to find because they're all on the back side. But yeah. All right. Questions on any of that? How is your phone already out?
I'm trying to get on.
Okay. Can we put it away till I'm at least done talking? Okay. Guys, I can already tell who's been doing the homework and who has just been copying the answer key. I don't care if you don't have homework done. You're just like, I tried really hard. I got this stuff done. I'm going to ask questions and I'll get it right. Just keep pushing at this. Now is not the time just to copy the answer key because proofs keep coming. And if you don't learn how to do them, you're going to keep struggling on every single test because proofs become harder and harder and are worth more and more points as we go. So now is the time to ask questions and get it. Real quick, I want us to look at our homework. And particularly look at number 4. And watch some dance moves happening. All right. So if I look at number 4 with you guys, I did not give you enough spaces. So you could put a little star by that I don't have enough spaces to do this correctly. I want us to look at this together. I was going to put it on there as just kind of a thing you could do on your own, but I want us to look at it together. What did I do wrong in 4? I mean, obviously I said it is done incorrectly. What did I do incorrectly? Tito?
You use substitution when you have a congruent.
I use substitution when I use a congruent symbol. I do want to put up that this is wrong, but on the test you might lose only half a point. You might even get all points if I feel generous enough. So the correct way would have been to say that 5 plus 8 equals 180. 2 is equal to 5, and then use substitution and gone back. That would have been the correct way to do this. But I just want to note that perfection isn't the only way to get most of the points. This would get most, if not all of the points. But this is done incorrectly. So if you copy this down, make sure you put it's done incorrectly so you know why it's done incorrectly. You have room for the rest of them to do correctly, though. Yeah, Griffin.